Hello and welcome to this session on Steel AI. My name is Prasad Joglekar. I'm based in California, United States, and I'm AI specialist, specifically applied AI specialist when it's applied to complex industries like the steel industry. Today we'll be talking about cutting edge AI technology and how it's applied to one of the most fundamental industries, which is steel business. We'll talk about a pathway to address some of the most pressing challenges faced today by the steel industry and how they can be addressed using Steel AI. Here's a problem description. So, there is a lot of moving parts in the 164-year-old steel industry, and it has seen multiple changes historically, but the pace of change has increased more recently. Generally, the demand has outpaced the supply. And although the industry has extremely challenging operating conditions, supply chain, distribution chain, and international geopolitical and energy exposure, there is a great opportunity now to leverage Steel AI, or what we call as Steel AI, to address some of the problems faced by the steel industry. There is many moving parts in various parts of the supply chain and workflows in the steel industry. There is regulatory compliance, and there is operational efficiency and safety related issues, and also emerging technology disruptions. We'll talk about some of the advances in AI technology and how they can be used to address some of these challenges. Steel industry already uses a lot of AI, and some of the AI technologies that are used in the industry include uh, AI for identification of faults, forecasting equipment failure times, forecasting various furnace conditions, including temperatures and so on, forecasting demand for steel of various types. Then there is collaborative robots used. We'll talk more about how some of the problems of allocation of resources when it comes to collaboration can be addressed using Steel AI, for which solution doesn't exist today. Uh, but there is no runtime what if scenario analysis or plan B AI available today, which is proposed value add of the Steel AI that we'll talk more about. The table stakes AI, as we call them, uh, include the production process related AI, which is already in use. Uh, there is forecasting, optimization, anomaly detection for quality control, then AI supported collaborative schemes. Uh, then there is generative AI and language models for customer interactions and automating certain expert advice and interactions and so on. But these are the table stakes AI, which are also part of Steel AI, and then there is something more that we'll talk about. The novel Steel AI that we're proposing uh, is kind of a control system for control systems, because there is a lot of perturbations that can happen, and we need to provide a solution that has zero hallucinations, that is real time, meaning it's responsive to changes as they happen in the system. And then we need to have a plan B for almost every part of the operation of the steel industry, without drudgery, meaning without having too much difficulty in terms of either the time taken for finding the plan B or resources taken for finding plan B. And this is something that we cannot do today, that our Steel AI solution is proposing to do. um, we need to be resilient to various types of disruptions, and at the same time we need to optimize the allocations in a really agile and quick fashion. And these disruptions might include anything from market related condition changes or changes in energy costs, supply chain delays or disruptions, and even technology shifts. For example, there is new technology trends that are happening. For example, electrolysis of molten oxide. That's something that's emerging very quickly, and the steel industry has seen a lot of technology changes over the last 164 years. It's just that the pace of those changes has increased, along with emphasis on green steel. And there is also currency changes happening with the world geopolitics. There is seasonality changes, specifically seasonality associated with green hydrogen or green energy, green fuels. Uh, they are inherently more seasonal in nature. For example, windmills or solar energy and so on. And the steel production runs 24/7. So how do we incorporate any shocks uh, in the energy market, either in production or in costs, in the steel industry? So that's something that we can address using AI, the steel AI that we're proposing. Now, we did talk briefly about energy management, and energy management and carbon caps are a reality, and they're getting a lot of attention in steel manufacturing and transportation. So today, the worldwide steel market is about 1.8 billion ton market, and it's expected to grow at a fast pace till 2050. And there is various different types of different forecasts, and but most of them agree that the increase is going to be the demand and increase is going to be greater than 50% by 2050, as compared to what it is now. And in general, the steel industry over the last 100 year has seen significant amount of growth every 20 years or so. So most of the steel that's made today, about 70% or so, uses traditional manufacturing methods like blast furnaces and basic oxygen furnaces and so on. So that's undergoing some change, and it produces, because it produces about 1.9 tons of direct CO2 emissions per ton of steel produced. And on the other hand, there is more greener technologies, and they include electric arc furnaces, and they include electrolysis, either electrochemical methods or electrothermal methods, that have a much lower emissions of carbon dioxide per ton of steel produced. And there is targets given to the steel industry uh, to meet by 2030 and then by 2050. And we need a migration path for this energy management. Now, most of the energy sources which are renewable are seasonal in nature, and we need to have uh, the production of that energy in sync with the consumption of that energy in steel plants, and that needs to be much smarter than what we do today. So that's where steel AI has some very interesting solutions of allocation. Then there is climate change regulations. So while steel is going to get more expensive, either with or without green energy and green hydrogen, just because of the demand and because of the some of the caps placed by governments on carbon emissions. And AI can help with the migration path. For example, as the steel industry is experimenting with different types of reductants, say for example, when it needs to go from methane to hydrogen, uh, what AI can do is provide a non-disruptive or a non-forklift type of path, which is a migration path to gradually replace methane with hydrogen, and keeping the bottom line of the business as an objective function. So it's a bottom line aware dynamic resource allocation is what is needed for addressing a lot of the steel manufacturing changes and a lot of the steel supply chain changes and a lot of the changes involved in how the steel industry workflows are managed today. Another big issue with the steel industry is that it presents some of the most challenging working conditions in terms of how the manufacturing staff or how the manufacturing workforce force deals with a lot of different aspects of the workflow. Extremely high temperatures, uh, high exposure to bright lights and sounds, uh, which attracts a lot of safety policies by governments and by companies, and they require controlled access to many areas of the steel manufacturing plant. So, for example, when the cranes are active in certain areas, only authorized personnel can access that part of the plant. And anytime there is a melt shop operation that has about 160 Fahrenheit temperature, uh, any person who is going to fix a problem there, say for example a broken crane, can only be there for 15 minutes, and then the person has to have a certain skill set, and the availability of those people. is reducing by the time. And then even though they're replaced, some jobs are getting replaced by robots, there is still a huge allocation problem just in terms of what needs to be accessed when and for how long. And it presents a huge problem in terms of dynamic resource allocation based on skill sets, uh, in a way to keep all the workers safe. So the human safety uh, requires a certain amount of intelligent scheduling, intelligent uh, allocation of workforce to work. At the same time, there's a lot of optimization involved in terms of keeping the plant running 24/7, even though some parts need to be replaced on a frequent basis. For example, the rollers. They need to be replaced because of the high temperatures every few minutes or so. You need to keep the operations going 24/7. At the same time, you have inherent risks, and then how do you manage those risks in a intelligent fashion, such that you can apply the right skill sets of the people to solve the right problems at the right time, uh, without exposing them to risk. In case of arc furnaces, in addition to the heat part, there is also really bright lights, for example, that can cause blinding effect on people. So that also requires exposure limitation for people to those hazardous working conditions, and that means that you need to pay attention to how to best do the allocation, especially when the skilled workforce is shrinking. Uh, Another really important aspect of the steel business is the end to end supply chain. And recently, geopolitical events, wars, global shortages of raw materials, then supply route disruptions, pandemics, climate related disruptions, instability in the markets, all of these things cause a lot of supply chain disruptions. And that can impact the how smoothly the workflow gets conducted in a steel manufacturing plant or even in steel trading. So what Steel AI does is it's a plan B AI, which means that you can do a lot of what if type scenario analysis. What if a certain type of disruption happens to a supply chain? What if B2B transaction introduces a lot more delay because of supply chain disruptions? What's the fallback plan? Uh, what alternate sources, what multipathing can be used? What delivery options can be explored? So there's a lot of, and all of these in an optimal fashion. So the Steel AI really focuses on optimizing Plan B in case there is disruption in business, and that's in addition to all the table stakes AI that we talked about. There's also various other types of AI using, for example, computer vision and robotics, um, for accessing certain hazardous areas where humans cannot be there, which is part of the process part. But then there is also other types of disruptions caused by not the steel manufacturing process variable per se, but because of global variables. Which are mentioned here, like geopolitical events and so on and so forth. So, an AI solution needs to be taking care of all of the factors in control as well as outside of the control of the steel business. And then you need to do a lot of what if analysis. And what Steel AI proposes to do is doing all of those optimized plan B scenario analysis. So you're ready with a solution before it happens. And you have much more ability to absorb the surprises, and still keeping the business profitable. Another feature of Steel AI that we're proposing is federation. So, in a federation of companies, there is certain amount of data that can be shared and certain amount of data that cannot be shared. For example, the sales data is more sensitive data that every company is going to keep private to itself, whereas the overall market data, in terms of market trends and seasonality and so on and so forth. Uh, for example, especially as 27% of the consumption of steel is in automobile industry today, but that can get replaced with polymers or aluminum and so on. So there is technology trends outside of steel industry that can be forecast, and then it's of interest to all the players in the steel federation to share those modeling, the results of that modeling in the overall picture, in the bigger picture, in the broad brush picture. And they want to keep their own personal data private because that's related to that company. They might be legally required to keep that private. So that's where federation comes in, which means that the members of the federation of the steel industry can share the models of certain aspects of forecasting and certain aspects of optimization without sharing the actual data that data is involved in making those models. So there's various types of federated AI, but the general idea is that there is a centralized server that contains a combined model, and it's only the model that's shared across various players in that federation without actually sharing the data. And this can be leveraged quite extensively by the steel industry. And because it's all a real time solution, so what we are focused on is solving plan B AI problems for steel industry in near real time, which means uh, in a really fast response type approach, in an agile fashion. So, for example, here is a parallel I draw between having a map to go from point A to point B versus having a step by step navigation, a live navigation system. So for example, if you have a disruption like a traffic accident, which is equivalent to a supply chain disruption, it takes you to the nearest path without really causing too much disruption in the end-to-end picture. So you're still going to have the vehicle go from plan A to point A to point B, but it has much more ability to be resilient to a lot of variables that impact that path, or that impact that workflow. And this is what we're proposing as the Steel AI solution. And last but not the least, so this is our elite team with a lot of experience in AI, as well as a lot of experience in the steel industry. And both industries are seeing an inflection point, and the time is right for using the cutting edge AI to solve the most pressing problems in the steel industry, especially in presence of so many uncertainties, where we can use a lot of plan B optimized AI solutions to deal with those variables in a much more resilient fashion, in a much more cost effective fashion, in a much more energy efficient fashion, and a safe fashion, for making a win-win situation for steel industry by applying and all the members of the federation of the steel industry by applying cutting edge AI. Thank you very much, and I'll be open to any questions that you might have.